I hereby open this academic session in which Gianluca Galazzo will defend his thesis, Intestinal Microbiota Assembly and Dynamics in Health and Disease, a focus on longitudinal data analysis. I got that in one sentence. So I wish you all the best and good luck in the coming hour. And the floor is yours. Please present a summary of your study and conclusions of your thesis.
Thank you. Dear Prorector, dear members of Corona, dear family, friends, and colleagues. In the next 15 minutes, I would like to present to you the result of my thesis titled Intestinal Microbiota Assembly and Dynamics in Health and Disease, a focus on longitudinal data analysis. But first, let me explain what is the microbiota and why it is so important for us. As a species, humans evolved to host an incredible amount of bacteria, virus, and fungi that are called microbiota, and they can be found all across the body, such as airways, skin, vagina, and within the gut. Only in the colon, each and every one of us can host up to 1 trillion of those microorganisms. As a term of comparison, in the gut of one single person, there are 100,000 times more living organisms than people on planet Earth. As hosts, we provide a rich environment in which the bacteria can thrive, and in return, they help us in digesting food, producing vitamins that we do not produce ourselves, interacting with the other organs, protecting us from external pathogens, and helping our immune system to recognize good bacteria from bad bacteria. In a way, we could consider the gut microbiota as a fully integrated additional organ that performs unique functions and is able to communicate with the other organs. And as for the other organs in our body, disruption in its function have been linked with several diseases, such as atopic diseases, inflammatory bowel disease, and post-infectious irritable bowel syndrome. But how did we learn about the beneficial effect of the gut microbiota and its link with diseases? The majority of the knowledge that we acquired in the past decades have been based on studies in which 2 or more groups of people are compared to find if and how their gut microbiota is different. This type of study design is called cross-sectional, and although it allows for the identification of differences between groups, it cannot distinguish if those differences are a cause or a consequence of the disease. Another type of study design that has been used consists of a group of subjects that are followed over time. This type of study design is called longitudinal, and besides the same advantages of the previous design, it also allows to follow the changes that might occur. But more importantly, if the subject under study might develop a disease, this type of study design helps us understand if the changes in the gut microbiota precede or follow the onset of the disease. For those reasons, this type of design has been applied in all the studies in my thesis. Together with the study design, another important piece in our quest to understand the gut microbiota is the technology. The study of the gut microbiota is as old as microbiology itself, dating back to its founder, Antony von Leeuwenhoek, and his observation of the different bacteria present in his mouth and in his feces. But the revolution occurred with the introduction of special machines able to read the genetic code and therefore tell us which bacteria are present in a sample without the need to observe them. Although this method was indeed a revolution, it also introduced a new problem since the data that are generated with this approach are proportional. To better understand why this is an obstacle, let's imagine that in our gut there would be only 3 bacteria species in the amounts that are shown here. Therefore, let's imagine 30 cells of Escherichia, 20 cells of Bifidobacterium, and 5 cells of Bacteroides. We could therefore describe the composition of the gut microbiota either using this absolute abundance or using the proportion of the total amount, like displayed on the left. The second type of data can be very useful for example, to compare samples of different size. But unlike the absolute data, proportions are influenced by variation even in only one of the components. Let's see what happens if, for example, only the amount of Escherichia increase. Although only one component increased, all the proportion result changed. And this happened because proportional data are forced to sum up to a fixed value, in this case 100. And because of this characteristic, we cannot apply the same statistics and analysis technique that we can use on absolute data. Therefore, the final goal of my thesis was to investigate the role of the gut microbiota in health and disease, with a focus on finding ways to overcome some of the issues that arise from proportional data, as well as to promote longitudinal studies as a way to overcome this problem. To reach that goal, I will first present a method to circumvent the proportionality of the data. Secondly, I will present advantages of longitudinal studies on understanding the maturation of the gut microbiota in early life. And finally, I will show the advantages of longitudinal studies to understand the changes of the gut microbiota in individuals with different diseases, such as atopic conditions, Crohn's disease, and post-infectious irritable bowel syndrome. A few moments ago, I mentioned that the proportional nature of the gut microbiota makes it impossible to apply traditional statistics and analysis methods. One way to circumvent this problem is to convert the microbial proportion back to absolute count by multiplying them by the original bacterial load of the sample. To achieve this goal, we explore three different approaches. We counted the intact bacterial cells, we counted the molecules of bacterial DNA, and finally, we counted the DNA molecules coming only from intact cells. Unfortunately, not only none of the tested methods led to reliable results, but also each one of those methods introduced additional bias into the data. For this reason, in the rest of the studies presented in the thesis, we decided to overcome the proportionality using computational methods. So far, we approached the investigation of the gut microbiota more from a mathematical point of view. But what about the advantages of the longitudinal designs? As I mentioned before, longitudinal studies allow us to observe changes in the microbiota that occur over time. For example, in one study, we followed 98 children that were sampled right after birth together with their mothers and followed up to 14 months of life. This design allowed us to explore the maturation of the infant gut microbiota and to compare it with the maternal one. Moreover, the recording of extensive additional data such as the diet of the infant, place and mode of delivery, and presence of siblings and furry pets gave us the possibility to identify factors that are affecting the maturation process. So how does the development of the gut microbiota look like? The evolution of the gut microbiota is displayed in this plot that depict the change in the abundance of the bacteria between the first 14 months of life. In the horizontal axis, there is the age, and in the vertical axis, there is the bacterial abundance. As we can see, the maturation of the gut microbiota is a dynamic process characterized by high abundance of bifidobacterium and Escherichia for almost the entire first year of life. After which, their abundance starts to decrease, and bacteria like Fecalibacterium and Blautia start to increase. Additionally, we found that the maturation of the gut microbiota is influenced by different factors at different stages. Specifically, during the first 2 weeks of life, the mode of delivery largely determined the composition of the gut microbiota. From 2 weeks up to 9 months of age, the main actor became the duration of breastfeeding rather than the age of introduction of solid food. And from 9 months onward, the diet is the driver of the gut microbiota maturation. In a similar study, we examined the gut microbiota development of more than 400 children during the first year of life, but this time in relation with the development of the atopic diseases later in life. The combination of the longitudinal design with such a long follow-up allowed us to observe that children that developed atopic dermatitis had less diverse gut microbiota compared to children that did not develop the disease. And not just that, we were also able to observe that among atopic children, a less diverse gut microbiota was associated with higher chance to develop the disease earlier in life. So far, we've been focusing on the gut microbiota in children, but longitudinal studies can be very helpful in understanding the role of the gut microbiota in adults as well. This is the case of our study on Crohn's disease patients. In this study, we explored the gut microbiota of 57 adults suffering from Crohn's disease to investigate if the gut microbiota was involved in the progression of the disease course. Our results show that the gut microbiota of Crohn's disease patients is less diverse compared to the gut microbiota of healthy subject. But in contrast with previous cross-sectional studies, the richness and diversity of the gut microbiota doesn't play a major role in the disease progression. In the course of our investigation, we stumbled across an interesting scientific mystery. The gut microbiota of a small group of patients was characterized by a low abundance of Fecalibacterium that could not be explained by age, disease behavior, location, or history, as well as medication used or surgery procedures. A mystery that definitely calls for further investigation. The final study I will present aimed to explore the role of the gut microbiota in the onset of post-infectious irritable bowel syndrome in travelers that experience traveler's diarrhea. This study involved 106 Dutch intercontinental travelers, all of which experienced traveler's diarrhea, but only half of them developed PI-IBS. The opportunity to study the gut microbiota before, during, and after travel gave us the opportunity to observe that subjects that will develop PI-IBS have a lower microbial richness as an altered gut microbiota compared to subjects that do not develop any symptoms. In relation with the altered gut microbiota, we also observed that travelers that developed IBS were enriched in bacteroides both before and right after travel. These observations suggest that alteration in the gut microbiota prior to travel might set the condition to develop PI-IBS. In conclusion, with my thesis, I hope I've supported that quantitative microbial profiling is an interesting approach to overcome the proportionality of microbiome data, but not applicable yet. Furthermore, longitudinal studies have the potential to unravel the temporal association between the changes in the gut microbiota and disease. In other words, what comes first, the disease or the change in the gut microbiota? And finally, longitudinal study help us to identify changes over time and also which factors are affecting these changes. We have come a long way in our understanding of what the gut microbiota is and why it is so important for us. But a long way has yet to come. It is time for the microbiome research to move to the next level. It is time to increase the effort to move from association to causality, to create new analytical methods specifically meant for microbiome data, to shift our attention to functional profiling, and to think how to address the yet unanswered question when designing new studies. Because a deeper understanding of the role of the microbiota alteration can help us developing strategies to shape the gut microbiota that could prevent or alleviate the condition of people affected by allergies, Crohn's disease, and IBS, and therefore has the potential to improve the quality of life of millions of people around the world. Thank you for your attention. I give back the words to the director.
Dear candidate, thank you for your very insightful and beautiful presentation. We will now proceed with the defense, but not before I introduce for the viewers outside this room the promotion team, Professor Savukul and Dr. John Penders, right opposite of me. They are not allowed to ask questions because they have pestered the candidate enough during his career. So the real questions will now come from the persons next to me. And the opposition will be opened by Professor van Schoten, who is Professor of Genetic Toxicology at this university. The floor is yours.
Thank you so much. Respected candidate, congratulations with this very nice piece of work that you have done. It's a very complex thesis you have written, very complex, the microbiome and the development of that. So I admire your courage that you all came all the way from Italy to dive in this subject here in Maastricht. And I've learned a lot, and I have a lot of questions I would go over with you. But I want to start with chapter 4. In chapter 4, you used machine learning, random forest, to predict the microbial age during development in early life. And in that respect, you have trained a model using the microbial composition of healthy children, and then try to predict the microbial age in healthy subjects. So that was only briefly described, and I wonder, can you explain to me what you did in, let's say, layman talk?
Highly esteemed opponent, thank you very much for your kind words and for your question. So the machine learning approach that we used in chapter 4 is called random forest. And the idea that is kind of shared between many machine learning is that we use some data to train the model, to let the model learn how to recognize something. In this case, we use the microbial composition of the gut of healthy children, and we let the algorithm learn how to guess their age. So once we train this model, therefore giving their microbial composition and telling to the software, look, with this microbial composition, we have this age. Then we applied this trained model to the children that would develop the atopic diseases or atopic conditions in order to see whether the predicted age was in line, for example, with the one from healthy children, or if it was different, because then there would be the interesting part to understand if there were difference, what this could mean.
And so you have a training set and a test set. So in this case, what's then the predictive accuracy of this model? What are the, let's say, is that 90% accurate or?
No, in our case, when we tested the accuracy of the model, it was around the 70%.
Okay.
So the model, in terms of machine learning, it might not be the highest in terms of accuracy, but is not because of the machine learning approach or the data themselves, but is the nature of the data, the gut microbiome data that are very hard in order to be used with machine learning methods.
Okay. So I was wondering, you did not use machine learning to predict microbial composition in relation to the disease. So can you also build a model based on this microbiome to see, to predict whether a person becomes sick, let's say atopic eczema or asthma? So you did not do that, did you?
No, we didn't.
Is that possible? And if you, how would you do it then? Looking at the longitudinal data you have, what kind of models can you use then, or what kind of technologies? Also random forest or others?
Well, there are definitely other possible machine learning methods that could be used in general. And what are you suggesting, like building a predictor model that use the gut microbiota to predict the future status,
exactly.
Definitely could be done. I still would go for the random forest for the same reason I was specifying before, meaning the nature of the microbiome data, their sparseness, their compositionality, the fact that even different bacteria can show different type of distribution makes very hard to pick different types of machine learning, because each one of them has certain requirements. For example, they might require that the data that are used to train the model are normally distributed, something that the microbiome data rarely are. So I would still go for something like a random forest, because the robustness to deal with these problems, keeping in mind that, of course, there are some limitations because of the data. So maybe in the future, if this problem could be solved, it could be able, for example, to apply super vector machine or even neural networks in theory, if we could normalize or make, let's say, data more appropriate for machine learning.
So can you then take a sample of a young child and then predict whether the child gets eczema at a few years later?
With a good model, it could be done.
Okay. Oh, that would be nice. Okay, that's very good. I do not know whether I have time for next question. So I want to ask about the first proposition. So maybe one of you paranims could read this first proposition.
Quantitative microbiome profiling can bypass the compositional nature of microbiome NGS data. However, substantial additional bias may be introduced depending on the laboratory methods used to determine the bacterial load.
Okay, thank you so much. Just a general question. Why is it so important to deal with this compositional nature of microbiome and GS data? Why is it so important? Can you explain to me as a toxicologist?
Well, the answer is very related with what we just discussed in terms of if we would be able to actually work with quantitative data, so in a way, let's say absolute abundances. In a paper from 2020 from Gian, it was clearly proved how the data, the quantitative data in microbiome studies, they are highly red skewed. And this means that in theory, we could apply some data transformation to make them normally distributed. So that is one aspect. Having quantitative data could help us to deal with some of the problems that now we're facing with analysis approaches. And another reason of going with quantitative, the importance of trying to search to create quantitative methods it comes directly from the paper from Van de Putte in 2020 that proposed originally something, the quantitative methods that in theory, the microbial load could actually explain a lot when investigating the relation of the microbiota with certain diseases. For example, in their paper, they found that Crohn's disease patients, beside the typical known outcomes, so lower alpha diversity and a lower Faecalibacterium, they also found out a lower microbial load. And this actually it's something very interesting to investigate because it could have interesting repercussion.
But what does this mean for most of the papers which have not looked at these microbial compositions? So what does this mean? Because many studies have not looked at this. Is that right?
Yes, it is true.
So these studies are kind of worthless?
Absolutely not, because of course depends on what is the final aim of the paper. Like in this specific case, certain quantitative methods can be used, as I said, like to understand if it could be explained part of the response that we could not explain now, as only a small percentage of the variance can be explained with our analysis, could help us shed a bit more light. On the other side, of course, like there are many analysis methods that still are very reliable even with the relative type of data. So it's just to add an additional tool in the tool set.
Okay. So I have so many more questions. I can do it maybe later, but my time is up, and I give the word back to the prorector.
Thank you very much. The proposition will now be preceded by Professor Venema, who is Professor of Gut Microbiology at this university. The floor is yours.
Thank you, Mr. Prorector. Dear candidates, congratulations on the completion of your thesis. And I would also like to include the promotion team in those congratulations. Also, congratulations on a very clear presentation that you did before here. For me, reading the thesis as the reading committee, it has been some time ago, in May, I think it was, that I read the thesis, and it was a good refresher of what was in the thesis. Clearly, I also have some questions for you. And I would like to start in chapter 2, where you compare some methods for quantitative profiling, right? And you kind of use the digital droplet PCR as also a comparison or as a golden standard, because you say that this method is more precise, discriminating, and reproducible. So my first question on that is, before I go into the science, is why did you then not use that method throughout the thesis?
Highly esteemed opponent, thank you very much for your kind words and for the question. if I well understood your questions, it's like you're asking why we didn't apply to other chapter. Well, the answer is that what we claim at the end of chapter 2, when we explore the possibility of the quantitative methods, is that as they introduce actually right now more bias than more insight, then we decided to use bioinformatic approaches in order to overcome the proportionality. So that is the reason why we haven't used either the approach, the quantitative, the QMP with digital droplet, but even with other types of methods, because right now the technology is not mature yet.
Okay. And I actually have a question on that, which may be the reason, but I don't know, so I'm asking it to you. I noticed that different primer sets were used for the quantitative microbial profiling that you did and the digital droplet PCR. Could that maybe explain some of the variation that is observed between methods?
Well, that is not my area of expertise, but what I can imagine is that the reason why we observed such bad results, if also I well understood your question, like you are asking if the quantitative PCR, the QMP based with qPCR gave such a bad results. Is that correct?
Well, and different results than your digital droplet PCR, right?
Okay, well, the reason is that I can imagine is the nature itself of certain bias that are present with a normal quantitative PCR. So, for example, if the saturation of the DNA structure of the primer affinity and primer coverage, and in theory with the digital droplet PCR, in which you repeat this process so many times, you have more consistent, you can take kind of an average, so you are not linked with only one type of result.
Okay. Yeah, I think you mentioned a number of items with respect to the primers that might explain some of the variation between methods. Then I would like to take you to chapter 4 on page 143. There are two sentences on that page, one in the middle and one in the bottom, that I am going to read out for you. And then I'm going to combine those sentences and then see if it's still logical what you conclude in that chapter, okay? So the first one in the middle reads that a longer duration of breastfeeding was associated with lower microbial diversity, okay? The second one says a lower microbial diversity is associated with an increased risk of atopic dermatitis. When I combine those two, I read breastfeeding is associated with increased risk for atopic dermatitis, where I think the consensus in the research field is actually the opposite. Can you explain where my logic fails?
I wouldn't dare to say that your logic fails. The only the explanation in this apparent contradiction is that the second sentence, the one that was linking a lower microbial diversity with higher risk of developing atopic dermatitis, comes from an analysis, actually the joint modeling, in which we actually corrected for the breastfeeding, for the duration of breastfeeding. So with removing this aspect from the analysis, we still found out in this association. So the two sentences actually cannot be, let's say, combined just in this way.
Well, I'm glad. So it still means that breastfeeding is protective. All right. Then chapter 3. In your discussion on page 109, you mentioned that altogether the results point towards the role of the maternal fecal rather than the vaginal bacteria as the inoculum. I wonder whether you can conclude that. Did you actually determine the composition of the vaginal microbiota to see what that looked like and how that compared to the infant microbiota?
Well, we did not, in this specific study, we did not sample the vaginal microbiota, but we traced back the bacteria that were shared from the mother and the child, and those bacteria are typical from the gut. So in this sense, there was kind of, we could confidently say that the bacteria found in the baby, were if they were the same from the mother, were coming from the gut microbiota of the mother. So,
but you cannot exclude that they are also present in the vaginal microbiota of the mother.
Not with absolute certainty, no.
Okay. Well, you're very fast in answering my questions. I think there's still some time, right? And I did have other questions available, so I'm going to ask you one which is more hypothetical. Also, in the same discussion of chapter 3, you discuss about sampling the meta community around these infants, which I think is extremely interesting. Yes. My question then is, if you would get like €1 million or something like that, how would you set up such a study with respect to number of individuals, the frequency of sampling longitudinally, and things like that?
Well, as we did in this chapter, we defined the meta community in this specific case, like all the bacteria that were present in the entire population. What could be also interesting in this context, it would be also to sample the actual environment in which those children are, how to say, they're born and they are firstly exposed to. But I can really imagine that collecting so much samples, so many samples, and so many metadata, because they are as valuable as the data themselves, it could be very, very expensive. So that's kind of what we already see in the literature. We have very high, big cohorts in which the number of metadata or the number of, some additional type of investigation are reduced because of the cost, or very small tailored studies. So in the sense of, to answer your question, I would see to investigate the role of the meta community, I would see more the second case, like something a bit smaller, but very in-depth, with a very in-depth samples. And the amount of samples that I would see, they are not at the end very little in terms of, so different in terms of the one that we already see. More specifically, probably it could be interesting to see the very, very beginning if there is something that might differ, but at the end, a number of sampling like the one showed in chapter 3, I think it's quite good.
Okay, so €1 million doesn't give you a lot yet, so we need much, much more money in this research field. Okay, thank you very much for your answers. I give the word back to the prorector.
Thank you very much. The opposition will be now continued by Dr. Bogaerts. He is from the Department of Epidemiology and Data Science from Amsterdam UMC. Thank you very much for being here and traveling all the distance in the Netherlands. So the floor is yours.
Thank you, Prorector, and thank you, Promoter, Co-Promoter, for inviting me to this defense. And of course, respected candidate, congratulations with this thesis. I'm much impressed by the breadth of topics, the depth of analysis, and also the combination of classical epidemiological thinking in terms of study design, confounding bias, and state-of-the-art data science techniques. So well done, and in some respects, it is work that I would like to do or have done myself. And you know that we work together, well, we at least had some discussions, still work together until COVID. Well, our project got sidetracked and you finished the current thesis, so congratulations. Of course, I do have a lot of questions, actually much more than I'm able to ask here, but my first questions would be on chapter 4, which I think is a nice case study of the various statistical models that are out there regarding longitudinal data analysis. But my first question in this chapter relates to the use of logistic regression modeling to see which factors are associated with the clusters that you defined by means of mixture modeling. And then a sentence that mentions how you did this was To illustrate the progression of samples through each cluster with age, we applied, a regression model. But it's not so much the samples that progress through clusters, but individuals. And of course, the hallmark of longitudinal data analysis is to capture dependency between samples within an individual. How did you do this within the multinomial regression framework?
Esteemed opponent, thank you very much for your words and for the question. Well, it is possible in this type of framework of the logistic regression, like to work also taking into account indeed the connection of the samples. So if samples are coming from the same individual, it is possible to include this aspect inside the model itself. So basically we are introducing a parameter that actually can track and say, this group of samples belong to the same individual. So take this into account when drawing the trend of the model itself. So that is basically using some random intercept, a random factor basically, and this include indeed can compensate.
Because it was not mentioned that you used a random term as well. I couldn't find it in the output in the tables, but I'm glad you did. So that satisfies my question. Another question I do have is regarding the prediction of some macrobiota parameters in the first year of life to see if they are associated with asthma or allergic sensitization in later life. And for that, you use all time points in the first year. And you conclude that some time points are predictive for asthma and others are not. But I do think that these time points are also highly correlated themselves. Can you actually conclude that if one time point has a significant association, that the other time points are not predictive?
Could you please repeat the question?
Okay, so I wouldn't want to go to the tables, but let's see if, for instance, in the output that is listed when predicting, let's say, asthma. So that is supplementary table would be 16, I guess. Yeah. So then you use the microbial maturity mass score at 5 weeks, 13 weeks, 21 weeks, and 31 weeks. And in this case, you conclude that the mass score at 5 weeks is significantly associated, but the others are not. But if they are all kept within one model, I think that the effect that is already taken by the mass at 5 weeks also takes out possible effects of other weeks.
Well, in this model, when we tested the mass score in the different time points, we also kind of include the effect indeed of the fact that there are repeater measures. But it's also, in a way, it's also partially compensated by the fact that it's not directly the output of a measurement in this case, because it's the mass score itself. So part of this direct association might be mulled out. But I can agree with you in terms saying that there might be some kind of correlation with some previous data that we could explore, let's say, further.
Okay, so you would agree with me that finding a significant association at 5 weeks would not rule out a possible association if you had only used, let's say, 13 weeks also in your prediction?
It doesn't necessarily, but what I would say is that in this case, we were looking specifically like to single time points for the association. So that's also, we were indeed looking at this early type of events. So it cannot be completely ruled out, but.
Okay. And then I also have a question on the joint modeling, which I was very pleased to see in your thesis. But I do had some doubts about the interpretation of the elevated hazard of that's shown in figure 4. When you actually on the right left hand you plot the effects with the p-values, and on the right you plot the development of some biomarkers, the diversity and the maturity among children that did develop atopic dermatitis and those who did not. Now, in a joint model, of course, people belong to a risk set until the event has occurred, and then they would no longer count as being at risk. My first question is, can children only develop or be diagnosed with atopic dermatitis once in this data set? Or is it an event that is possibly recurring?
Well, in this case, it's the diagnosis is the recognition of the diagnosis. So they are diagnosed only once, and this was also like our focus, like up to what age they are indeed recognized as children with atopic dermatitis. So it's not a recurring.
No. Okay, so it is a time to event, but if you plot the trajectories of these biomarkers, do you take those out who had already developed the event, or are they still kept in?
Could you please repeat the question?
Okay, so you plot the development of, let's say, diversity over time in the first year of children who are at risk of atopic dermatitis and developed, and those who were at risk and did not develop. But the classification who developed or not is of course made at the end of the entire follow-up. Did you use this definition at the end of the entire follow-up to plot two groups, and once they developed, were they taken out of the risk set for the biomarker that you show?
Well, in the creation of the joint modeling, eventually once they develop the disease where they diagnosed, they are ruled out. But so this, in this sense, this is kind of the answer to your question. So they are ruled out, and therefore the trajectory kind of keep having.
Yes, I just wonder because I was a bit worried by the crossing lines that I saw in figure D. I just wondered if this could be explained as an artifact, or if it's really a crossing line, and if that's the case, there should have been an interaction with time in the model, I think.
It might be. I mean, in this case, we cannot exclude completely this opportunity, but what I would say is that you kind of have this type of the possibility of artifacts. They're always present when you create certain prediction models, or when you make this type of projection. And in this case, this crossing, it might be improved in terms of if we had more children. But we observed exactly the similar type of pattern with the mass score itself when we studied the behavior of the mass score. So in this case, we are pretty confident this crossing is actually what is happening and not a kind of an artifact.
Okay, well, in that case, I think you could have considered taking an interaction with time in the model. But do I have time for one more?
No, sorry.
Okay, thank you.
Yeah. Okay, I take the word back and give the word further to Dr. Mujagic. He is from the Division of Gastroenterology and Hepatology from Maastricht University Hospital. Welcome, and the floor is yours.
Thank you, Proctor. Dear candidates, I would also like to congratulate you on this great piece of work. I very much enjoyed reading your thesis. And also congratulations to your promotion team. quite marvelous work, starting from infants towards diseases in gastroenterology. And as a gastroenterologist, you probably would expect that I am most interested in chapter 5 and 6 of your thesis. To start with a short question on chapter 5, we have 2,000 travelers, of whom 53 at the end have post-infectious IBS that are included in your analysis. Just small numbers when I was thinking about it. In my head, I always had the idea that about 30% of people who have an infection develop IBS at the end. But then I thought I'm missing a piece of the information because I don't know how many of these 2,000 had an infection or diarrhea during their travel. Do you have that information? Do you know how many people at the end after travel develop diarrhea?
Well, I list him opponent. Thank you for your question and for your words. As we say in this chapter, we made a nested study. So the combat study is a much bigger study with a different aim, actually, because the aim of the study is to study the carrying of the antimicrobial resistance in travelers. And within this study, we make a subset of patients indeed that developed the travelers diarrhea, and that subsequently some of them developed post-infectious irritable bowel syndrome, and some other were just matched within indeed the study. So I imagine, as far as I know, we don't have the information about if all of them, but I mean, we have for those 53 or for these 106 patients, we have this information, of course, but I cannot say for the rest of the 2,000 travelers of the combat study.
Okay. And did you have any information that you could use to know for sure there is no selection bias, that you don't have a specific group of patients within these 53? Are they representative for all post-infectious IBS patients?
Well, as described in a recent systematic review, actually the kind of population in our cohort is kind of reflect relatively well what is the demographics of people suffering of IBS. So, for example, the majority also in our study were women, or yeah, I mean, in general, they were kind of quite good reflection of the overall demographics.
Okay. I see, of course, a lot of IBS patients and IBD patients, and they quite often ask questions about the gut microbiota and how that relates to their symptoms or their disease, and also how we can modulate it. My answer is mostly that we do a lot of research as a scientific community on this topic. We know much more now than we knew 10 or 20 years ago, but at the end, for daily clinical practice, it's still not useful. So I don't have any drug or treatment for them that is directed for their gut microbiota, well, depending on prebiotics, probiotics, etc. But these are also, when you look at the guidelines, always indicated with a lot of caution because the studies are quite heterogeneous. So I was quite happy to see that at the end of your talk that you said, we need to go from finding all these associations in cross-sectional studies towards more studies directed towards causality, longitudinal, etc. So I would like to discuss that point with you with regard to this specific study. You say at the end, we identified an altered profile preceding the onset of IBS in the gut microbiome. And you say quite nicely after that, the results strengthen the evidence for a causal role of gut microbiota and pathophysiology of IBS. Could you speculate a bit more on that? Is it proven now that there is a key role for gut microbiota and IBS, or in this case, post-infectious IBS? Or could it also still be just an epiphenomena that we measure using while doing these studies?
Well, there are there is a staggering amount of evidence that point towards the role of the gut microbiota. Like there are at least 2 big systematic reviews published in 2020 and 2021 that actually kind of summarize indeed all the findings. And so the suggestion, how to say, the clues that the gut microbiota, it is involved, they are piling up. So on that respect, I would say that is not, we can say quite relatively confidently that it definitely plays a role. In order that is different anyway to say it is caused by, or in which way it's causing the IBS. So I would say, of course, that the gut microbiota plays a role, but to go in the details in what is the mechanisms in which the gut microbiota have an effect on developing the IBS, then this needs further investigation, although there are some kind of consensus. Like the results are really similar in a way to what are the knowledge with the IBD. So in general, it's found that people with IBS have less alpha diversity, so they have a less rich microbiota. They can have less beneficial bacteria like Faecalibacterium or Bifidobacterium or Bacteroides. But what is actually a problem in terms of deciding or choosing, like, okay, we can say this is a signature, and then we can focus our effort in understanding that, is because, like you were mentioning before, there is a lot of heterogeneity. Like there is a systematic review from Canopy on 2020 in which clearly stated out that almost the 70% of the studies have a different type of, there is a lot of heterogeneity in that. So they're not really comparable one another in terms of results. And this makes very hard in order to, I'd say, boil out the information and therefore drawing some more deeper knowledge on which to focus our effort on this, to go from association to causality.
Yeah, I agree. So there's probably a key role, but we still are not sure. Is there time for more questions, or is it
a very short one?
Oh, I have a longer one, so I'll leave it up to the. Thank you very much for your answers, and I give the word back to the prorector.
Yes, thank you very much. Now the defense will, the opposition will be preceded by Dr. Stassen, who works at the Department of Medical Microbiology at Maastricht University Hospital. Welcome, and the floor is yours.
Okay, thank you very much, dear candidate. First of all, I want to congratulate you and also your team, of course, with this excellent thesis. I think this thesis contains more tables and figures, and some of them are really little pieces of artwork that I've ever seen in a thesis. And this actually represents how thoroughly you analyzed your data and wrote 5 extensive experimental chapters in which you describe how microbiome develops during the first phase of life, but also whether it's associated with disease. And although I'm not a mathematician, nor a statistician, or an epidemiologist, I've read your thesis with interest, and some of your findings are quite intriguing. You know that I'm always interested in what all these associations mean, and how we should interpret them in a more physiological and perhaps pathophysiological context. And this is also how I read your thesis. What do all these analyses mean, and how can we use them? And in this respect, I came across some interesting findings, and I would like to discuss this with you. First of all, I really like your approach. I completely agree that longitudinal studies are far superior than cross-sectional studies, because you examine subjects as their own control. Okay, now let's come to the question. In chapter 5, you described that the microbiome of travelers who develop post-infectional IBS have a different microbiome than travelers who do not develop post-infectious IBS. The microbiome, lower richness, lower diversity, and this difference is maintained during and after travel. This suggests that such an aberrant microbiome might be used as some kind of a biomarker. However, how can we define whether the microbiome is indeed predicting for post-infectious IBS? So we need some characteristics of a microbiome which we can define as being at risk. How would you define such a microbiome? Because in your study you could compare it to your healthy controls, but now you need some objective characteristics to say, okay, if you have this composition of your microbiome, you're at risk. Be careful.
Esteemed opponent, thank you very much for your kind words and for the question. If I well get your question, you're asking like, how can we create some kind of baseline or draw a threshold after which we can decide, okay, this is a risk microbiota? Well, there is not an easy answer to this question, because until now, we even don't know what is a healthy microbiota. So it's even harder to decide what is unhealthy microbiota. For now, what we are doing is compare it with healthy subjects and try to find some signature, of course, some specific type of bacteria, some certain characteristics of the community, of the microbial community, that could lead to a hint that this could lead in developing certain diseases. And this is basically what we have done throughout the thesis, also in chapter 5. What I would suggest to do is indeed like to make us as researcher actually giving us ourselves more tools in order to explore more what is the effect, the role of the gut microbiota, what the bacteria actually do. But also one thing that is very important is some kind of consistency, some kind of standards that the researcher should start, we should all start using more, because as the opponent stated, there is a lot of heterogeneity. So if we cannot even compare the studies among themselves thoroughly, then how can we start drawing what are the signatures? So in a way, I would say that one way in order to reach this, to be able to draw this line, is also like to improve our knowledge in general and combine also some other outcome of my thesis. So in terms of being able to in a way, being more sure of the data that we have, we can actually be treated, like for example, building prediction models or building some classifiers that would help us in order to at least starting picking up some of the signature and therefore start going in the direction that you were suggesting.
Okay, so still some work to do. Okay, also in this chapter, what thing that intrigued me was the finding that the post-infectious IBS developed after GI infections during traveling. But when you look at the age distribution of these patients, which was between 25 and 50, it's very likely that they experienced some gastrointestinal infections already earlier, before traveling. So why did they develop this IBS, this post-infectious IBS, not earlier, at an earlier stage? Why was it necessary to travel before this IBS appeared?
Could you please repeat the question?
Okay, these patients obviously will have experienced some kind of gastrointestinal infection before traveling to Asia, Africa, whatever what. Yeah, and earlier, as a younger guy or girl or whatever what. I mean, everybody experiences every now and then a gastrointestinal infection. Yeah. Mm-hmm. Why didn't they develop this IBS already at an earlier stage? Why did they develop only after traveling to foreign countries and coming back, and then the IBS symptoms appeared?
Well, one possible answer could be the fact that, as we state at the end of the chapter, indeed, some changes in the gut microbiota could predispose, and therefore, like having a radiant microbiota, a weakened type of microbiota, then after the infection can become the trigger. but only if there is a kind of weakened, in a way, microbiota. So in this sense, it could be some differences that comes with the lifestyle.
Dear candidate, you can either choose now to answer or finish the question quickly, or be silent forever, at least on this topic. So,
okay. Yeah, basically what could happen is that some changes in the lifestyle indeed that people experience could lead to those changes that we identified, and therefore, after exposed to the trigger, then led to the post-infectious IBS.
Okay. I have some follow-up questions, but time's up. So,
okay, thank you very much.
Thank you for your answer.
The degree committee here present has assessed a number of things, and we will now retreat because the time appointed for defending your thesis has passed, and you already had the idea. So we will now withdraw and discuss the quality of your thesis and your defense, and I request that you and your company stay here and await our return. And we will now adjourn to the committee room. Thank you. In view of its positive verdict, and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Paul Savenkool is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor now to take the floor.
Dear candidates, do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
I promise.
By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Gianluca Galazzo, the degree of doctor and grant you all the rights attached by custom and law. As evidence of this, I now present you with a degree of certificate signed by the director, the secretary, and the other members of the committee, and affixed with the official seal of the University of Maastricht. Dear Dr. Galazzo, dear Gianluca, I'm honored to congratulate you as the first with this highly honored doctor degree, but of course, John Benders will do the laudatio.
Dear Dr. Galazzo, dear Gianluca, you've succeeded, and that deserves a big congratulations, and I can imagine the relief. Because especially in the past few weeks, you have indicated how stressful you have experienced these past few months. However, today you have shown that these worries were absolutely unnecessary. Congratulations. And I would also like to extend my congratulations to your partner, George, your parents, your brothers, and all other family and relatives. Your journey as a PhD student started about 5 years ago when you applied for the PhD position in our lab. And already during these very first interviews, you marked all the stereotypes of an Italian guy. As you were back in Sicily, the interview had to be online, and maybe we should say the monologue, because Paul and I prepared a list of questions we wanted to ask, but after 1 hour, I think we only were able to ask 2 or 3 of them, because your answers were extremely lengthy, and it was very difficult to interrupt you. Probably the only interruptions were the moments where your mother came into picture to adjust the curtains, and you shifted your attention from the interview to a lively discussion with your mother. And at first, we really thought that this was all a coordinated strategy to avoid difficult questions. But soon we learned that you really are such a chatterbox. And when you arrived in Maastricht and started your PhD, it also took us some time to understand each other. Literally, because during one of the first meetings, I indicated that would be interesting to focus on longitudinal data analysis. And you went back and studied and searched the literature. And after 2 weeks, you came back and said to me, John, you know what? There's no such thing as long tunnel analysis. So I had to explain after 2 weeks that it was really something different that we wanted to do. And who would have thought that now it would be the title of your thesis? Also, my repeated warnings that you should always lock your screen when you leave your desk were not really heard at first. And it was only after I put a post-it on your screen with a message from Pete from the Data Privacy and Security Department that you had violated the privacy rules and that you should call him back to justify yourself. With a trembling voice, you called, not knowing that it was my cell phone number. And then, of course, Lina and I had a blast. But it only learned you a message, and I think you understood. Unfortunately, there's also something like payback time. We will leave that story for later. Your first paper, or should I call it Anita's paper, that's the way you called it, it went really smoothly, and soon you reanalyzed all the data, and the paper got published. But thereafter, the real challenge began with the data from the PUP study. Longitudinal microbiome data combined with atopic diseases that manifested at various ages in participating children. You tried different approaches, many of which were soon abandoned. The sparse data, the compositionality, the fact that each taxon appeared to have its own distribution, it did not make things easy. And it was a windy road that brought us in contact with many different people from all of different disciplines, from quantitative economics to learn more about Granger causality, to the biostatistics group of Dimitris Rizopoulos at the Erasmus University to learn more about joint models. And there was only one thing that was in common with all these meetings, and that was that you had always more questions than everyone could answer. And I think that critical attitude has also significantly contributed to the successful publication of this paper in Gastroenterology. I know you had a strong desire to also include longitudinal network analysis into the paper, and you've tried and tested hard. But even without that, I think this paper is of very high quality and well received by the scientists in the field. And this is also evident from the many posters and oral presentations you gave on this study. At the International Human Microbiome Consortium Congress in Killarney, the World Microbiome Conference in Milan, and also the Scientific Spring Meeting of the Dutch Society of Medical Microbiology. I particularly recall the nice road trip from Dublin to Killarney, together with David, Lina, and Niels, the good whiskey, the Irish folk music, and your questionable disappearance all the time. Maybe you can inform us on that later. Your biostatistical skills not only improved your own papers, but many other papers in our research group and beyond. However, in terms of wet lab and field work, you failed big time. Although we have tried several times to get you into the lab to only at least process one single fecal sample, we haven't succeeded. However, you at least consented to participate in collection samples during one of your trips to Sicily. We never received the samples though, because apparently the collection kit was eaten by the family dog. Seriously? Talking about eating a food, this was the topic of many conversations, from your colorful descriptions of the food fests when you visited your family back in Sicily, to the do's and don'ts in cooking and baking. And many of us had the opportunity to experience your cooking skills. Always delicious, only too bad that the portion sizes were always so tiny. During the past few years, you had many successful publications, but you also struggled with parts of a PhD that you really disliked. The writing, the many unknowns, the uncertainties, and the small steps that were taken. And you soon realized that you did not aspire a career in academia, but rather would like to work as a supportive data scientist in a more applied setting. And you've recently started at Vendetta Biosciences, and I'm confident that your skills will flourish over there in a new position. And especially now you've taken this last hurdle of your PhD, you have all the time and efforts to focus on that. So once again, congratulations, take a deep breath, and let's celebrate.
Dear Dr. Galazzo, congratulations also on behalf of the Board of Deans of this university. We're very proud of you. You had an excellent defense and an excellent thesis, so congratulations. Enjoy the day. We will now conclude this session, and we will take pictures at the stairs, and also congratulations can be done at the stairs, and the rest of the company can already leave for the festive location. Probably has to do something with food, I guess, which is typically Italian. I already hear that a lot of people will have a good treatise being there. So enjoy the day, have a fantastic day, and also congratulations on having a good job in Boston.
Thank you.
I conclude the session.